Hi, this is Alex from devstories.eu, LangChain v1.0 Orchestration Framework, Episode 6 of 20. If you rely on a language model to properly pass an authentication token or a user identity to a database tool, you are setting yourself up for a massive security breach. The model does not know who the current user is, and it certainly should not be trusted to guess. You need a way to pass sensitive backend data directly to your tools, bypassing the model entirely. This is exactly what injecting tool context resolves. When you build a tool, some arguments are meant for the model to generate, like a search string or a date range. Other arguments are strictly for your backend infrastructure. This is where the ToolRuntime object comes in. It allows you to inject static configuration into a tool exactly when it executes. You might think you can just pass a configuration dictionary as a normal tool argument and tell the prompt to ignore it. Do not do that. When you define a parameter named config or runtime in your tool function, LangChain treats these as reserved keywords. It intentionally hides them from the tool schema that gets sent to the language model. The model never sees them. It only sees the arguments it is responsible for providing. This means the model cannot hallucinate a fake configuration or attempt to override your security boundaries. Consider a concrete scenario. You are building a Get Account Info tool for a banking application. The tool requires a user ID to fetch the correct database records. If the model provides this ID, a clever prompt injection could trick the model into requesting data for a completely different customer. Instead, you design your tool function to accept two arguments. The first is the account type, which the model will provide. The second is an argument named runtime. Inside your main application code, before the tool is invoked, you populate this runtime object. Specifically, you use the runtime.context property. You place the actual authenticated user ID of the person making the request directly into this context. You might also place an active database connection or a regional endpoint address in there. The model evaluates the user request and decides to call the Get Account Info tool. It looks at the schema, sees that it needs to provide an account type, and outputs the word savings. It outputs nothing else. LangChain intercepts this execution call. It takes the account type from the model, seamlessly combines it with the runtime context from your backend, and executes the Python function. Inside the function, you extract the user ID from the context and run your database query securely. This mechanism gives you secure dependency injection. You can inject anything your tool needs to function that the model has no business knowing about. API keys for third-party billing services, file system paths, or tenant identifiers in a multi-tenant architecture all belong in the runtime context. Here is the key insight. Hiding configuration arguments behind the runtime context ensures your model acts purely as a logic router, while your application code retains absolute, uncompromised control over data access and execution security. Thanks for spending a few minutes with me. Until next time, take it easy.